Today we're going to just do a little bit of review and some more examples of the stuff that we've been covering for the past couple of weeks for a test that we're going to have on Thursday, covering Boolean algebra or basic gates, Boolean algebra, and minterms and maxterms are going to be covered on the test. So we're just going to do some review of anything that you want to go over, any examples that you may need to work through. Happy to take suggestions. You want to just do like minterms and maxterms? That's the newest thing. All right, we'll start with a state table. And we'll have, let's see here, 1, 1, 0, 0, 1, 0, 0, 0. All right. So what are the max terms, or I'm sorry, the min terms for this state table? Where do you get the ones? 0, 0, 1, yeah. Well, why don't we start with this one? What's the min term for this one? X prime, Y prime, Z prime, because they're zeros. Okay, and the next term? Yeah. All right. And the next term? Yeah. X, Y prime, Z prime. So that's the min terms. Now this could be reduced down a little bit. Well, how could this be reduced using Boolean algebra? What about these two factors here, these two terms here? Distribute out the x prime and y prime. So it would be x prime, y prime times and z prime or z. Right? See what I did there? Okay, now what's z prime or z? What is that? One. So it'd be x prime, y prime, 1, or x, y prime, z. And then and a 1 with anything, and you get? Yeah, you could just drop the 1. So x prime, y prime, plus x, y prime, z. Oh yeah, you're right. I dropped the prime here. All right. Yeah, that would about do it. You might be able to factor out the y primes. Oh, I didn't bring the book, but this would be sufficient. That's if you have a situation where you have fewer ones than you have zeros. If, on the other hand, you have more ones than zeros in the out, you would choose to, you might choose to do max terms. So there'd be fewer terms. So so your max terms are ORs with the inverse of the max term or minterms. So you would look at the zeros and get the max terms, which would be, what's the first zero here? What would the max term be for that? Exactly. X plus y prime plus z. Okay. And then the second one? Plus y plus z prime? Mm-hmm. And then finally, yeah. Now reducing this is it is a little bit more challenging and not necessarily necessary. You can often leave it in these terms, though you could probably factor out the x prime and z prime here of those. So you would have what is it? X plus y prime plus z, and x prime plus z prime, uh, I always forget how the let's just leave it in that form right there. Now, the shorthand for this, if you look at the binary value of these numbers. You got 0, 1, 2, 3, 4, 5, 6, 7. You can write this shorthand as pi, capital Pi, 2, 5, 7. Because those are the max terms that are used in the expression. So when presented with this notation, you can easily translate it into this here and into the Boolean expression up here. With the, or you could do it as a sum. This is the equivalent to the sum of 0, 1, 3, 4, 6. Because those are where the ones are. So these are max terms. And these are minterms. So the shorthand notation is the product of sums here, or the sum of products here. I'm not going to write out the Boolean expression for all that, for the product of sums. I mean the sum of products. But when you have this notation, you look at how many terms there are, and the value of those terms, if nothing is, let's see here, 4, less than or equal to 4, it's 2 variables. Less than or equal to 7, you have 3 variables. Less than or equal to 15, you have 4 variables. So in this situation, if presented with this or this notation, you could see that the number of the terms is less than or equal to 7, so you know that this would be 3 terms, or 3 variables, which is what we have here. Because, oh, I'm sorry, this is less than or equal to 3. Sorry. But if you're given a notation with, say, pi, the product of 1, 4, 8, 11. It's greater than 7, but less than or equal to 15. So this would be 4 variables. And you would write out a state table with 4 variables. In the max term location, you would put zeros in the 1, 4, 8, and 11 row and construct your product of sums expression from that. If you are given without any direction as to whether you should be in max term form or min term form, go with it, whichever one has fewer terms. This one has 3 terms. This one has 5. So it would be easier to write out the expression in 3 terms. So you would pick the product of sums form. Whereas if it was switched around and this was 3 over here, you would do the sum of products form. Whichever one's easier. Because the fewer terms is going to have fewer gates. So you can determine from these forms, these notations, the form that you can express it in. But is this making sense? Kind of. This is a little bit new, but the minterms and max terms we covered. I know we covered last week, but let's do a. Oh, sorry. Okay. Let's do another example from the let's do, you're given my marker is dying. Product 0, 1, 3, 6, 7. What does that notation tell you? Yeah. There's going to be more zeros than ones. Yes. Yes. So which form would be more efficient to express this in? Exactly. So what is the equivalent notation with the sigma? Do I have that backwards? Am I getting my sigma wrong? Yeah, but no 8. 2, 4, 5. So we're going to have three variables because the highest term is 7. So we're going to have ones in the 2, 4, and 5 locations and zeros everywhere else, right? So what would the minterm form, the Boolean expression, be for this? What's the second minterm? Or number 2 minterm? No, it's not plus, it's times. Because it's minterms. And then you plus the number 4. D prime. That's the fifth, number 5 minterm. Yeah. So F would be equal to that. Yeah. And that would be your expression that you can build a circuit from. So there you go. Okay. Going through this pretty quickly here. Let's see here. How about that? Do the minterm? No, that's minterm. That's the sum of products. But it has 3 terms greater than 7, so you need 4 variables. Which, if 4 variables, has how many combinations? 16. Okay, it's greater than 15. Yeah, it's less than or equal to 15, but when you have n variables, you have 2 to the n combinations. So 3 variables has 8 combinations. 4 variables, because the terms are greater than 7. You would have 4 variables, 2 to the 4th combinations, or 16 combinations. So an expression with n variables has 2 to the n combinations of inputs. I'm sorry? No, 2 to the n, not n to the 2. So 3 variables has 2 to the third power, which is 8. This one is going to have 4 variables, so it has 2 to the fourth power, which is 16. So you have 16 combinations, 16 possible terms. And here you have 1, 2, 3, 4, 5, 6. So which would be better, 6 or 10 terms? Exactly. That would be a lot more efficient. And we'll do you can I don't have the space the way I have this laid out to do all 16 combinations on the board, but you would do the 16 combinations of inputs, W, X, Y, Z, or A, B, C, D, doesn't matter, and put the ones, because this is a sum, you'd put ones in the 0, 1, 2, 8, 11, and 12 positions, zeros everywhere else, and then create your minterms from that state table. But, yeah, this is let's see here. What would that look like? The pi 0, 1, 3. How many variables will you be using? 2. So let's say x, y. Now you have 4. So you have 4 combinations because it's 2 to the second power. Which term would you want? Which would you rather have? 3 terms or 1 term? 1 term. So do the equivalent of that, which would be, what's the missing term? 2. So you would put a 1 in the, this is 0, 1, 2, 3. You put a 1 here, 0 here, 0 here, 0 here. This is f of x and y. And you would have just this term here is x, y prime. Obviously, that can't be reduced any further. But yeah, that's That's pretty much the extent of the minterm and maxterm usage, and what will be on the in that section of the test this coming Thursday. Still got plenty of time. Any other topics that you want to cover? Yeah. If you used if you say you did 3 variables here, kind of a thing. The zeros and ones are determined by the numbers in the simplified expression. So the positions of the zeros and ones wouldn't change. What variables you call them might change, but the zeros and ones remain the same. So I'm not exactly sure what you're asking, but did that answer your question? Yes, no? Oh, doing the doing this section. Oh, okay. Well, let's just go ahead and I'll erase this because we're gonna need the room. And add a 4th variable, W. This would be all zeros. And then this would be all ones. See, you would add another column if you're going up beyond 7 to 16. You would add another column, W, which would be all zeros here, all ones here, and this part, these 3 columns would match these 3 columns. You see what I'm saying? So if you had the like the product of sum, the product of 1, 0, 1, 3. If you decided to use 4 variables for this instead of just 2, these would stay the same. The outs, this it would be 0, would be 0, 0, 1, 0, and then zeros for the rest of them. No, I'm sorry, there'd be ones for the rest of them. So, when you do the minterms or the max terms, all you're going to see is the, in this case, you would do the max terms. All you would look at would be the original 3, and W and X is the same regardless of those max terms. So they become a non-issue in the final expression. That could be simplified out and leave you behind with just the terms, these 3 terms. But yeah. Any other questions, or did I just confuse you a little bit more? No? Okay. But all right, well, we can have a short day today, but be prepared. Thursday, noon o'clock, test, Gates, Boolean algebra, minterms and max terms. All right, have a good day. See you on Thursday.